Bismillahirrahmanirrahim. The quote of the day is hope is like the sun, which as we journey toward it, casts the shadow of our burden behind us. Today, the topic of presentation is Z-test for mean under the supervision of Professor Dr. Saira Afzal. The learning outcomes of outlines of today's presentation is introduction to Z-test, brief overview of null and alternative hypothesis, formula to calculate Z-test, steps for solving hypothesis, and examples of Z-test. The learning objectives are by the end of this presentation, participants will be able to describe Z-test, where to use Z-test, calculating Z-test, and how to solve hypothesis. The introduction to the Z-test is that the Z-test is a statistical procedure used to test an alternative hypothesis against a null hypothesis. It is a statistical test for the mean of a population. Z-test is a statistical hypothesis used to determine whether two sample means are different when variances that is denoted by sigma are known and the sample is 30 or larger than 30. It is comparison of of the means of two independent group of samples taken from one population with known variance. Now we have a brief overview of the null hypothesis that is denoted by H naught. It is a statistical hypothesis that states that there is no difference between a parameter and a specific value, or that there is no difference between two parameters. The null hypothesis in it, population mean is always equal to the hypothesized population mean. It is a hypothesis which the researcher tries to disprove, reject, or nullify. The null often refers to common view of something. Now the alternative hypothesis that is denoted by H1, it is a statistical hypothesis that states the existence of a difference between a parameter and a specific value, or states that there is difference between two parameters. In alternative hypothesis, population mean can never be equal to the hypothesis population mean. It may be greater than the hypothesis population mean or less than the hypothesis population mean. The alternative hypothesis is what the researcher really thinks is the cause of a phenomena. In a statistical test, it equals to the observed value minus expected value over standard error. For the Z-test, observed value is the value of the sample mean. The expected value is the value of the population mean. Assuming that the null hypothesis is true, the denominator sigma over square root of n is the standard error of the mean. Now the formula of the Z-test is x bar minus mu naught over sigma over square root of n, where x bar denotes the sample mean, mu naught denotes the hypothesized population mean, sigma denotes the standard deviation of population, where n is the number of observations. Why we use large sample? When we perform a statistical test, we are trying to judge the validity of null hypothesis. We are doing so with an incomplete view of population. Our sample is our window into the population. The larger the sample size, the bigger our window. Over with the full view of population, there is always a chance that our sample will lead us to wrong conclusion. When do we use Z-test? When samples are drawn at random, when the samples are taken from population are independent, and when the standard deviation known, and last, when the number of observation is 30 or more than 30. Know the steps for solving the hypothesis. There are 5 steps for solving the hypothesis. First one is to state the hypothesis and identify the claim. Second step is find the critical value. Third step is to compute the test value. Fourth step is make the decision to reject or not reject the null hypothesis. And the final step is to summarize the results. Now step 1, that is state the hypothesis and identify the claim. First of all, we state the hypothesis, the null and alternative hypothesis. In null hypothesis, population mean equals to the hypothesis population mean, while in the alternative hypothesis that the researcher claims to be, in this the alternative hypothesis population mean can never be equal to the hypothesis population mean. It may be greater than the hypothesis population mean or less than the hypothesized population mean. The second step, that is to find the critical value. The determinants of finding the critical value are the level of significance that is denoted by alpha, and it can be 1%, 5%, 10%, or it can be any depending on the researcher. The level of significance is the probability of error in rejecting or accepting the null hypothesis. The second determinant that needs to find the critical value is the level of confidence that is denoted by cell C, and it can be calculated by subtracting the level of significance from 1. The level of significance refers to the percentage of all possible samples that can be expected to include the true population parameter. We also need the Z table, and it depends on if the hypothesis is one-tailed or the two-tailed. Now come towards the distribution curve. The whole area under the distribution curve is 1, and if we subtract the level of significance 1 from 1, we will get our level of confidence area. The level of significance area is the rejection area. If our null hypothesis falls under this rejection area, our null hypothesis will be rejected. And if our null hypothesis falls in this level of confidence area or the acceptance area, our null hypothesis will not be rejected. The line that divides the level of significance area and the level of confidence area is the Z line, that is the critical value. Note there, these are the ways how to find the critical value. For a right tail test, when the level of significance in 1%, 1% can also be written as 0.01. If we subtract 0.01 from 1, we will get the confidence area, that is 0.990. And if we see it in the Z table, the value that closely matches to the level of confidence, and if we add both the numbers in the rows and columns, we will get our critical line. And this critical line will divide the level of confidence area and the rejection area. If we null hypothesis fall in this rejection area, our null hypothesis will be rejected. And if our null hypothesis fall in this acceptance area, our null hypothesis will not be rejected. For level of 1% significance level, the Z critical value is 2.33 plus 2.33. And for left-sided tail test, the value is minus 2.33 and it is on the left side of the distribution curve. And for two-tailed test, we will divide the level of significance by 2 as it is on both sides of the distribution curve. And if we subtract it from 1, we will get our level of confidence area, and we see it in the Z table that closely matches to our level of confidence value. And by adding both the values in the rows and columns, we will get our critical value that divides the distribution curve. If our null hypothesis falls on either the side of the on either tail of the distribution curve beyond the Z lines, our null hypothesis will be rejected. And if our null hypothesis falls between the Z lines, our null hypothesis will be accepted. Now the third step is to compute the test value. For Z test, the formula as already been discussed is x bar minus mu naught over sigma over square root of n. Now the first step is to make the decision to reject or not reject the null hypothesis. Depending on the calculated Z value, reject or not reject the null hypothesis if it lies in or not in the rejection region respectively. Now the final step is to summarize the results. Summarize the results depending on the results and decisions to reject or not reject the claim. Now come towards the examples of Z test. The first example is of the right tail test. The example is that a researcher reports that the average salary of assistant professor is more than $42,000. A sample of 30 assistant professors has a mean salary of $43,000 some dollars. At level of significance of 5%, test the claim that the assistant professor earn more than $42,000 per year. The standard deviation of the population is $5230. Now, the solution for calculating it is, first step is to state the hypothesis, identify the claim. As in null hypothesis, population mean is equals to the $42,000, while in alternative hypothesis, as it is a right tail test, in alternative hypothesis, the population mean has to be greater than the $42,000 that the researcher claims. Then the second step is to find the critical value. Since the level of significance is 5% and the test is right tail test, the critical value is plus 1.65. The third step is to compute the test value. We will put the formula of the Z test, and when we put all the values in the Z test, the result will be 1.32. Now the fourth step is to make the decision. Since the test value plus 1.32 is less than the critical value of 1.65 and is not in the critical region, the decision is to not reject the null hypothesis, and it is also shown in the figure. As our calculated value of Z test is 1.32 and it is not beyond the Z line, so our null hypothesis will not be rejected. The final step is to summarize the result. There is not enough evidence to support the claim, and assistant professor earn more on average than $42,000 per year. Now the second example is of two-tailed test. The example is that the Medical Rehabilitation Education Foundation reports that the average cost of rehabilitation for stroke victim is 24,000 and some dollars. To see if the average cost of rehabilitation is different at a particular hospital, our researcher selects a random sample of 35 stroke victims at the hospital and finds that the average cost of their rehabilitation is 25,000 and some dollars. The standard deviation of the population is 3 to 5 $1, and at the level of significance of 1%, can it be concluded that the average cost of stroke rehabilitation at a particular hospital is different from 24,000 and some dollars? No, the solution for this example is, first of all, we will state the hypothesis and identify the claim. In our hypothesis, population mean is equals to the 24,000 some dollars, while the population mean is not equal to the 24,000 and some dollars at the such claims. Then the second step is to find the critical value. Since alpha is 1%, at the level of significance is the 1%, and the test is two-tailed, the critical value is plus 2.58 to 1 minus 2.58. Now the third step is to compute the test value. We will put the formula of the z-test and we put all the values of our example in it, and the value that we will get will be our z-test value. As in this example, the z-test value is 1.01. Then the fourth step is to make the decision. We will not reject the null hypothesis since the test value falls in the non-critical region or the level of acceptance area as shown in the figure. As this is shown in the figure that our calculated value of z-test is 1.01 and it is not beyond the z line. So our null hypothesis will not be rejected. The final step is to summarize the results. There is no enough evidence to support the claim that the average cost of rehabilitation at the particular hospital is different from 24,000 and some dollars. Now come towards the MCQ session. The first MCQ is, what test should a researcher use to determine whether there is evidence that the mean income of doctors in Pakistan is greater than rupees 90,000? Whether a one-tail test should be used, two-tail test should be used, either a one-tail or a two-tail test should be used since they are. Yes, one-tail test should be used as the researcher claims that the income of the doctors in Pakistan is more than 90,000. The second MCQ is, if a one-tailed z-test for a proportion is performed and the upper critical value is plus 2.33 and the test statistical is equal to plus 1.37, then what conclusion can you draw? Yes, the null hypothesis should not be rejected as the calculated value is 1.37 and it is not beyond the critical value of plus 2.33, so the null hypothesis should not be rejected. The third MCQ is, what is the region of rejection for a one-tailed z-test? Is it always greater than 0.05? Is it always greater than that for a two-tailed test? Is it found in the tail that supports the null hypothesis, or it is found in the tail that supports the alternative hypothesis? D. The correct option is the C. It is found in the tail that supports the null hypothesis. The fourth MCQ is there a sufficient evidence to reject a null hypothesis at a 10% significance level? Then there is sufficient evidence to reject it at 5% significance level. Select the best answer. C. Yes, it is C. It can be true or it can be false, because if our calculated value comes beyond the 5% level of significance, then it is true. But if the calculated value falls between the 5 and 10%, then it will be false. So the correct option is C. The fifth MCQ is, the mean value of iodine is expected to be lesser than the standard value of 20 mg in the people living at hilly areas. To test this claim, the researcher tested levels of iodine among 30 people of the hilly areas and found that the sample average to be 14 mg. What are the null and alternative hypotheses being tested? D. B. D is the correct option, because the researcher claims that the iodine level is lesser than the population mean. So the D is the correct option. The sixth MCQ needs calculation. Assume that the cholesterol level in certain population have a mean of 200 and standard deviation is 24. The cholesterol levels of random sample is 9 and individuals are measured and the sample mean is determined. What is the z-score for a sample of 180?
D.
Uh, we need to calculate it. We will put the z-test formula and we put all the values in it and the result will be minus 2.5. So the correct option will be beta. This is an extensive MCQ, so it needs to be attempted after the class. The MCQ is the mean half-life of a sample of 400 of a drug XYZ produced by a manufacturing company is found to be 10 hours with a standard deviation of 2 hours. Test the hypothesis that the mean half-life of drug XYZ produced by a manufacturing company is 13 hours against the alternative hypothesis that is greater than the 13 hours at 1% level of significance. It needs calculation. Do it after the class. Here is the key to the MCQs and here are the references, and thank you.